Okay, intermediate, what are we on now here? We're on, this is video 4, 10.7. Okay, let's try different varieties now. So this is actually a third degree equation because m times m times m is m to the third. These are already going to be factored for you in the homework, so it's not factoring them. That's actually, we would learn that in pre-calc. But I'm going to put this stuff in your homework. So they're already factored. So I'm going to do one that's going to be like your homework. So since it's already 0 on one side and it's already factored, you can skip those first 2 steps. You can go right to the critical numbers where you pretend. Sometimes I write CN instead of the word. I don't always realize when I do that. You're going to pretend that this equals to 0. So I'm going to get that m equals to -4, 7, and -1. So I'm going to put that up on the number line. And then I'm going to figure out, are my critical numbers included or not? So this has the bar, which means that they're included. Okay, like this. It means that they're included. And I'm going to pick test values. Okay, so here I'm going to pick -5, -2, 6. Oh, no, let me pick 0. 0 is always a good one to pick if you can. And 8. Okay, so again, you don't have to pick what I'm picking. You just have to stay within the segment. Just make sure you stay within the segment. Don't pick the critical numbers. All right, so here we go. You probably know how this works now, so I can do this one a little bit faster. Oh, -5. Let me write the right number. So you know how this works. I'm just going to, this is sort of repeat now. This is an m value. Okay. So a negative times a negative times a negative is -1 times 12 times 4 is 48. That's true because -48 is less than 0. So this guy is good. Okay, now I'm going to pick this guy. So same idea. I'm going to plug it into the original. Positive times a negative is positive. 2 times 9 times 8 is 18. So positive 18 is not less than 0. So this guy's false. This guy's not happy. All right, now I'm going to do m is 0. I'm on this guy. Okay, positive times a negative times a positive is negative. And then 4 times 7 times 1 is 28. And this is true. -28 is less than 0. So this guy's very happy. Okay, my last guy here, I chose 8. Okay, so what are we going to get for this? 18 carry the 1, 108. Okay, so positive times a positive times a positive is positive. 12 times 1 times 9 is 108. That is not less than 0. This guy's unhappy. All right, so once you get to the ending, just don't forget to write what the solution is. So the solution to this is this segment here, which is negative infinity to -4, close bracket, union, -1 to 7, close bracket. Okay, So just make sure in your final answer you include these 2 segments. And again, whichever way you want to write it is fine. This is better if you're comfortable with this, but either or is fine. Okay, gang, that's it on this one. Let me see if I can just get this last one in, because this is really it. This is all the varieties. So at the very end of the homework, you're going to do these fraction ones. And the fraction ones are the most challenging. So the first thing to do the critical numbers is where it's equal to 0. Now, if you have a fraction, let me just explain a concept. If you have a fraction, what makes a fraction equal to 0 is when the numerator is 0. It's not, the denominator should actually be a non-zero. Okay, so when I set this equal to 0, I'm actually looking at the numerator. The numerator is what makes the fraction equal to 0. From what you remember of domains, in terms of domains, just looking at the fraction itself, a cannot equal to -1. That's a domain restriction, right? Because when a is equal to -1, right, when a equals -1, I have -1 over, right, if I just plug that in, if people want to see that, that gives me -3 over 0, which is undefined. Right, when you divide by 0, that's undefined. That's what we would call a domain restriction. Domain restriction. So this last case is the most difficult because it has both a critical number and a domain restriction. And domain restrictions also go on the number line. So notice it's not just critical numbers, it's critical numbers and domain restrictions. They both have to go on here. Domain restrictions are always excluded, always, no exception. If you divide by 0, you cannot be included. Critical numbers will or will not be included depending on whether you have the bar or not. This one has the bar, so it's included. If there was no bar, then this one would also be open. So it's the same rules as before for the critical numbers. Okay, and then everything else is the same. You find your test value. Okay, so it's just that first part that's a little bit different, but after that, it's the same ball game. Okay, so let me plug in -2 here. So I picked my first value, I picked -2. A negative over a negative is positive. So this guy is true. This guy's happy. Ooh, that guy's got a big head. Okay, sometimes that just happens. All right, 0. 0 minus 2 over 0 plus 1. That's negative, so that's going to be false. We got an unhappy dude here. And at 3, that's true. 1/4 is greater than 0, so that guy is true. This guy is good. Okay, and then just as before, just make sure you write out your answer. -infinity to -1, open, close at 2 to infinity. So this is the domain where this fraction is, the graph of this fraction is above 0. Okay, gang, that's it for this. I do want to do one more section this week. I may or may not get it up online today, but I will get it up this week. And I guess for now that's pretty much the big announcements. Okay, just get the homework in because we're going to start reviewing for the finals soon. Okay, I'll catch you again at another point soon. Okay, bye bye.